Okay, make sure you have a graphing calculator. Do not be playing with the calculator in between problems. These aren't toys. We want to make sure that we're using them properly, not wasting the batteries. If your calculator starts to get low, we do have a charger with 10 slots. Some of them I noticed have actually started to become low. Anyway, we're using graphing calculators today to help us kind of visualize this, and it might be a little bit more fun. So today, after this lesson, you should be able to successfully write an equation in slope-intercept form of a line parallel or perpendicular to a given line. Just real quick, this is not on your paper, but non-vertical lines are parallel if they have the same slope. And the reason it says non-vertical is because if one's vertical and one's horizontal, they're going to be perpendicular. If two are both vertical, they're going to be parallel. If two are both horizontal, they're going to be parallel. That's special case. But they always will have the same slope if they're parallel. Perpendicular lines are lines that intersect to form a right angle. So if they're perpendicular, another way to tell is if you multiply them, you get -1. You multiply their slopes. So the point being, knowing what perpendicular mean, obviously if you don't know what the symbol means, kind of messes you up pretty bad. We're supposed to know it by now. Perpendicular, again, lines that form right angles. Notice that one of these has a slope going downhill, which is a negative slope, and one has a slope going uphill, which is positive slope. So they will always have slopes that are opposite signs. Okay? So that's why we say that if this line is parallel to a given line, it has the same slope. If it has a line is perpendicular to a given line, its slope is the negative reciprocal. Negative reciprocals of one another. What negative reciprocal means, well, flipped slope, this is just a weird way to say it, reciprocal. Slope and change sign. That's what you do to get it. I'm going to make some lines, equation, I'm going to make them up. And the way I can make them up real easy is because I know something about them. I'm going to write them in y equals m times x plus b form, or not, but I need to get them in that form so I can see m, which is your slope. So if I make some up for you right now, I say y equals -2x minus 3. A line parallel to that must have the same slope, so what number must match? The -2. Okay, so it could be -2x plus 5. Okay, these lines would be parallel, okay, because they have equal slope. Okay, so they have the same slope. The slope number again, right here. Some equations of another way, let's see, what if I had y equals 1/3 x minus 1? Well, a line perpendicular to that might have, not perpendicular, I'll do those over here. Parallel to that has to also have a slope of 1/3. So what if I had 3y equals x plus 2? Or I'll make it not be 2 just because you probably won't like it when I do the next thing. I'll make that be a 6. All right, what can I do to tell if it is parallel to the line above it? Well, first of all, it has to be in y equals form. How would I do that? What do I have to do to this? How do I get rid of the 3? Oh, thank you. I didn't hear those. A little louder. Good. Divide by 3. Do you see now that now I can see the slope is 1/3 x plus, and the y-intercept was 2? All right, so these are parallel because the slope numbers actually do match. Sometimes you have to solve. I don't know what's funny about this, but let's see. Next one, we're going to talk about equations of lines that are perpendicular. So if I had the same equation over here that I started with on the parallel lines, -2x minus 3. The line perpendicular to it would need to have a slope that is not -2, but flip 2 and change the sign, 1/2. Okay, so I just made it up and show you a way you look at the slopes. Now, why are these perpendicular? Because the slope of one is -2, the slope of the other is 1/2. Those are negative reciprocal slopes. Negative recip slopes. That's what we're talking about. Or you could say that -2 times 1/2 equals -1. Okay, I'll make up another pair for you. Say it was y equals, I'll just do, I'll do the 1/3 x minus 1, just like I did over here, and then I'll write a new one. If I have a line perpendicular to that line, it must have a slope that is not 1/3, but -3. Okay, so I could just write y equals -3x minus 1. Or plus, doesn't mean. I guess I just want a different y-intercept maybe. Okay, those would be perpendicular. So let's try writing some equations now. Anybody need this page? Okay. We're going to use the fact that we know slope is y2 minus y1 over x2 minus x1. We're going to use the point slope formula. Y minus y1 is equal to m times x minus x1, where you put in a point in for x and y. And so here's this process. You write an equation of the line that passes through the given points. You find the slope of the line, you put in a point, and you simplify to y equals mx plus b form. So let's do it. Here's what's on your paper. Parallel lines have the same slope. Perpendicular lines, negative reciprocal slope, which means to flip slope and change sign. All right, I am going to try doing these simultaneously almost. So, first of all, 0, -1 is my point. That's your x1, y1. Your line's equation is y equals -3 times x plus 4, where the slope is -3. That's your m. If your slope of this line is -3, what is the slope of the line would be parallel to it? It's going to be the same. So it would be -3. Okay, you need to start focusing now if you've been spacing out. Okay, slope of this line needs to be -3. The format or equation we use is y minus y1 equals m parentheses x minus x1. We're going to fill this in. For y1, we're putting in -1. So it's going to be y minus -1. For m, the slope, we're putting in -3. If you weren't here last Thursday, you still have papers you need to get from me. And this is going to help you with what we did that day. We're going to put in 0 for x, so x minus 0. Now it's time to simplify. Y minus -1 becomes y plus 1. -3 times x is next, and then if you do -3 times -0, there's not going to be anything. The last step is to solve for y by subtracting 1. So the equation is y equals -3x minus 1. Okay, to do the line perpendicular to this line that had a slope of -3, we need to take the slope, which was -3, and we need to flip it and change the sign. So if you flip it and change the sign, that's going to be 1/3. Taking -3 and writing it over 1, then flip it and change the sign. That's where I got 1/3 from. You're going to have to get over the fractions. They're going to be fractions. All right, that's for the line perpendicular. Now, we need to do the same thing we did over here, except this number, the -3, is going to change to 1/3. I'm going to write it out this time, but after this problem, I'm going to start using the fact that I've already done it once somewhat and fill it in. So we're filling it in the same. Y1 is -1. We're putting in 1/3 now for the slope and 0 still for x1. We're still simplifying it. And we still need to subtract 1. So this is y equals 1/3 times x minus 1. Okay, now here's the part I want to try to do something new with you. Did you have graphing calculators down at H9 last year in Algebra 1? So you probably have done this before on the graphers, yes? Something what I want to show you now. All right, let's try it again on these new pretty ones because they're color. So now's the time when I'd like to see you actually have the calculator open. Yeah. Okay, you could probably use it now, but then we'll need to plug it. We'll pop it in for me afterwards. That'd be great. Okay, anybody else say low battery? Okay, we're going to want to plug those in today if we could. I don't think they were very charged when I got them on Thursday. All right, we're going to clear. All right, okay. I need everybody to be at the same page. So everybody have the calculator in working order. Everybody's got one on? Because this is like the kind of nice part. Maybe it'll help you. Press this Y equals button on the upper left-hand corner. This is what you should see. Anybody not getting this? Okay, now let's put in our original equation for number 1. You have your paper next to you in front of you. All right? What is the first equation that it told us? We were finding, and it has to be in y equals form for you to actually use this. So what does it say y equals? Can I please have someone tell me so I don't have to look it up? All right, Emily? 3x. Oh, it was a negative 3x though? Well, wait. The original equation was negative 3x? Okay, so we'll push the negative button down here, guys. 3x. And then what was it, Emily? Minus 1? Okay, so this is the equation of the line. Okay, guys, I'm asking for, apparently we're not, I want to know the equation of the original line we were trying to find things parallel and perpendicular to. That's the answer right there. All right, so what I got from some people was ones that we found, which is okay. Just trying to make sure I'm getting the question answered correctly. All right, so this is our first line. All right, so would you do this, please? Just because I want everybody to see the original line. That's the whole point for right now. I'm going to hit zoom. So everybody has the same thing. You should see this screen. And then 6. Whenever you're feeling like your grapher isn't ready for you or something's not right, you can always hit zoom 6 because that'll make you go back to a standard window, right? So if somebody else was messing around with it, I'm trying to get everybody so we have the same picture. Is everybody seeing this? Anybody not seeing this? Because this is taking some of our time that I don't have to, but I'd think it's important that it's actually valuable. All right, let's go back now. This is our original line. What was the point of our problem? It was to find a line passing through another point that was parallel to it. And we found out that equation, so in y2 was negative 3x, and that's the one that you told me, Emily, was minus 1, right? All right. This line should be running in the same direction as the other line, and it should be at a y-intercept of negative 4. Okay, press graph. Okay, now here's what I want you to observe so you really understand your lines. Do you see the y-intercepts? There's your minus 1. There's your 1, 2, 3, 4. There's your y-intercept 4. That's why that's on the graph. because that's where it crosses the y-axis on our equation, all right? Slopes, these lines are both going down 3, right 1. How they move. Okay, you can see it. So now let's go into y equals again. And on line 3, let's have a look at the line perpendicular to these lines. So it has a slope of 1/3. Can someone tell me what was a -1 also with x? 1/3 x, and then -1, or was it minus? It was -1. Okay. So it's going to have the same y-intercept. It's going to cross the same place as this one. Okay, but it's not going to go in the same direction because it's going uphill. That's what we should expect. So you hit graph. Now I want to talk to you about the fact that it doesn't visually look like a right angle, does it? Okay, let's use some common sense, guys. This looks more like an HD TV. You know what I mean by that? The shape? Or like your computer screens now that have changed. They're not square anymore. It's rectangular. But this window is 10 by 10. Do you see the spacing? Look how much wider the little numbers are apart than going this way. It's stretched this way, wider than that way. And it's trying to fit the same amount of spaces in a bigger space, which means it's distorted. That's why when we went to the HD format, your TV, remember all your movies would come up when you play a movie that was at the theater and it'd say, this motion picture has been formatted to fit your screen. And it had to be squeezed in, it had to be stretched sometimes, or they format it so it's not stretched and look weird. They had to chop off part of the movie on the left and right. Now we have our HD, more of your, at that aspect ratio of 16:9, you actually have the movie screen set up now when you have a HD TV. Okay, I went a little further on. We'll talk about that more in the future, but here's how we can fix it. You can hit zoom so I can show you it visually that it is actually a right angle. Pick one. What would maybe tell you it's going to do that? I'm hinting. Square. Square it up. Okay, so let's do 5. Choice 5. And then it makes more numbers. It spaced them evenly. And it made more numbers horizontally, more spaces horizontally than vertically. So it's fixed it. It squared it up. You see the right angle now with the red line and that one? Or these both have right angles here. These are perpendicular lines. Got a right angle here and here. There's a bunch of right angles. Okay, so let's go back. If you go back to y equals, clear out those 3. We're going to try another set momentarily. Now you would set your calculator down because we're done with it for the moment. And we grab our pencil again and let's get busy on number 2. All right, so x1 is 2, y1 is 7. This line, y equals, is your original, and it has a slope of 1. So a line parallel will also have a slope of 1. The slope of the line perpendicular, if you take 1 and write it over 1 to make it a fraction, and you flip it, you still get 1 over 1. If you change sign, you get negative 1 over 1, which is just negative 1. Okay? Parallel line will have a slope of 1. Perpendicular line will have a slope of negative 1. Special case. Now I'm going to put it in y minus y1 equals m times x minus x1 format. Substituting in y1 is 7. I get y minus 7. Substituting in m is 1. I have 1 times x. And putting in 2 for x1, I have x minus 2. Okay, so I'm going to start simplifying. Y minus 7 equals x minus 2. I add 7 to both sides, and I get y equals x plus 5. Just a minute. Yes? Okay, thank you. Let's edit it later. Okay, no big deal. We don't need to hear that over the loudspeaker on the recording. All right, so we got x plus 5 here. Let's go ahead now. Look, I wanted to shorten things up here. I'm not going to rewrite this again. I'm just going to take this guy right here and change what? Change the 1 to a -1. Okay? That makes us go for it now. We're ready to go. Instead of rewriting all that, all we had to do is change the slope part. Y minus 7, distribute to -1. Have a good evening. -1 times -2 is +2. Okay, our next step, add 7. Well, that's a completely different equation. Y equals -x plus 9. Lots of hazards to live recording. Oh well. Ready? Let's try it on the grapher. Okay, first equation that I want in here would be the original line. Let's have a look at that. And I forgot what it is already. Y equals, Kayla, can you tell me? Kayla, sorry. Beginning again? Oh, just x plus 5. Thank you. Okay, let's see if it makes sense. Our original line looks like this. And it crosses 1, 2, 3, 4, 5. Well, you can just count it right there. Crosses at y equals 5. All right, we'll go to line 2. Our parallel line was x what? Plus, oh, it was the same line? So let's see what happens if we do that. Yep, it should write right over it. Okay, so when you visualize that, oh, look, that one's the same. Oh, it just changed color because it wrote right on top of it because we put the same thing in twice. And then the last one was -x plus 9. And now we can see those two and that one. And, whoa, nice right angle right there. That's what they should look like if they're perpendicular. Okay, did you get a chance to look at it and practice putting them in a grapher, I hope. All right, next one, number 3. I'm going to go a little quicker here. Oh, we got something to do on this one. We need to change that into y equals. How would we do that? What we need to get rid of? 2x, right? So we're going to need to take away 2x from both sides. And then we're going to write the x part first. So that'll be -2x plus 6. Now I can see my slope. It is -2. So the line parallel will have a slope of -2. -2 written as a fraction is -2 over 1. So if I flip that and change the sign, I'm going to have +1/2, yeah, for the perpendicular line. Okay, I am going to fill in my y minus y1 equals m times x minus x1 formula, which is point slope formula. I'm putting in x1 of 4. I'm putting in y1 of 5. So y minus 5, I put in my m, -2, and then x minus 4. Do you mind? Let's go ahead and, since we're doing these at the same time, I'm going to go over here and just copy that. And then I'm going to put in 1/2 instead of -2 for my slope. This one we're doing parallel, this one we're doing perpendicular. All right, let's work on the parallel line first. Parallel lines equation. Did it die on you? Thank you. Putting it in. Okay, so the equation of this line will be y equals negative 2x plus 13. And then the perpendicular line, distribute a half with 1/2 times a minus 4. Minus 2. Okay. You can always type it on your calculator, but I'm really thinking if you do 1/2 times 4, you should know that it's taking half of 4. Add 5 to both sides. Our equations y equals 1/2 of x. Negative 2 plus 5 would be positive 3. Did I go too fast for anybody? All right, want to go see how it looks in the graph again? Why not? We're going to have to put in, you can't put in this original equation because it's got to say y equals, so we have to do the one we worked on. So I hope we did that one right. I know we did, but kind of be a bummer for you, though, if you did it wrong in the first place. All right, so going to y equals and clearing out the last problems. Oh, what was it? Y equals negative 2x. Deanna, can you tell me the rest of it? 6. Oh, sorry. Carolyn. Good. All right, original graph is that line. If we go to y2, our new equation we said was negative 2x. I forgot what the y-intercept was. Plus 13. Ooh, kind of big. It's not going to show where it's crossing the y-axis, is it? Well, you can't, no, you can't see that, though. So you see why you can't see it? This goes from 0 to 10. And so 13's up here. Yeah, there is a way to change it so you could see it. You could zoom out, or you could actually mess with the window. You would want to change this 10 to a bigger number. So you actually can do it. It just won't stay square, though, and it won't look as nice. Like, say, if I put 15 in there, because I knew 15 is bigger than 13, then you could see it. And that would be 13 right there. All right, back to y equals. Line 3, let's see, the third line, we have 1/2 x plus 3, thank you. That should show everything. But because I changed the window, it won't look perfectly at like it's a right angle or not. It won't look like it. Okay, enough of that. Here we go. Got to see it. All right, here we go. We have to get this one into y form as well. So I'm going to have to subtract 2x. It's going to give me negative 5y equals negative 2x plus 10. And then I got to divide everything by negative 5. So the equation is y equals positive 2/5 times x. 10 divided by negative 5 would be negative 2 minus 2. That is my original line in y equals form. All right, now I need to write down that the slope of the line parallel would be the same as that one, so it's 2/5. What would be the slope of the perpendicular line? Okay, negative 5/2. Flip it over, change the sign. Perfect. In the format, y minus y1 equals m times x minus x1. You don't have to write that down if you know it already, if you've got it on your paper. We'll fill in the ISN tomorrow. We gotta just put in a 0 for both x1 and y1, which is not really going to do a whole lot here. Okay, so that's just going to be y equals 2/5 x. And if you do the same thing over here, but you just change the slope, that's not going to do much either. Oh, I shouldn't have plus 0. I should have had minus 0 if I'm being technical about it. Anyway, that's going to give us y equals negative 5 halves times x. Oh, so I already got the equations pretty darn fast on that one. Now, the difference between these and some of the ones we did, these two ended up having the same y-intercept, which is 0. If you want to look at them again, now I kind of forgot what my original one was. Is it 2/5 or 5 halves? I couldn't remember. 2/5. 2 divided by 5x. Then what was it? Minus. It was plus 2 for the original. Okay, so the original line looks like that. The parallel line also has a slope of 2/5, but it doesn't have anything, any y-intercept. It does have a y-intercept, so I'm saying that incorrectly. So let me clarify. The y-intercept is 0 if there isn't one. So it should go through 0, 0, and there we go. It does. The third line, negative 5 halves x, should go the other direction and go through 0, 0, running it into the red line at both of those lines at 90 degrees. You go back to zoom 5 if you want to square it up. And there you can see the right angles. Okay, let's try 5 and 6. Get just a few more together. Write an equation of a line that passes through this point, x1, y1, and is perpendicular. So now when you read these questions, it's not going to be always set up like it was the ones I was just going over, for example, where you got to do both. So if it just says find the line perpendicular, you have to pay attention and know that the slope of this line is negative 1/2. The perpendicular line, we need to flip and change sign. Okay, got to do both. So the slope of the line perpendicular would be positive, and flipped would be the number 2. All right, we used the format. We got a point where x1 is 8, and we've got y1 is 2. We're going to plug that into this format, or this point slope formula. So that's going to be y minus 2 equals 2 parentheses x minus 8. We're going to simplify by distributing. Distribute the 2 over the x and the 8. Then we're going to add 2. And the equation is y equals 2x minus 14. If I did things correctly, yes. You need this page still? Oh, no problem. All right, that's just the one equation. I believe the next one says to make a line parallel, doesn't it? Or does it say perpendicular again? A different set of values. All right, so 6 says write an equation of a line that passes through a point negative 1, 5, that's x1, y1, and is parallel, so it's going to have the same slope. So the m is going to be 3. x1 is negative 1, and y1 is 5. Okay, so you fill in the point slope formula with a 5 for y1, a 3 for the m, and a negative 1 for the x1. We simplify I'm going to change this minus a -1 to plus, and then distribute. 3x plus 3. Now you know why it's so important to be able to do algebra equation solving. Well, at least it's another good reason. 3x plus 8. How are we feeling? I hope not bad. Your hair looks adorable today. Okay. Always looks nice. Yeah, do some editing. All right. Determine whether the graphs of the following equation are parallel or perpendicular, and explain. All right, so I have just a few more examples here. We've got to look at the equations, and sometimes they're not all the way they need to be yet, Darylyn. So, just talking to you so you can pay attention over here. Look, what's the slope of this line? Did I forget that? No, it is. You guys thought I wasn't the other day. Okay, I'm going to edit some of this, obviously, because I'll just say what I was going to say. I am recording. It appears down here, and remember you thought I wasn't recording that one day? And then I thought I did too, and I just kept going. You know what I'm talking about? It was like Thursday or last Wednesday. Well, I was. And then after school, I had a whole bunch of kids in, and it was still going. It went for like an hour. And then I edited it. Anyway, I'm going to have to edit this one too. All right, what's the slope of this line? Hurry, please, come on, pay attention, stay focused. We're almost done. 5. Okay, what's the slope of this line? What's 10 divided by 2? Okay, these have the same slope, so they are parallel. Okay, number 8. You just have to write down parallel, guys. Write down the slopes and then write parallel or perpendicular or neither. On number 8, the slope number, the number in front of it. Remember, slopes do not include the x. It's just the location of the slope number. It's in front of x, the coefficient. This slope is 5/2. The slope on the second line is 2/5. These are reciprocals, but they're not opposite in sign. So this is neither. Okay? They are reciprocals, but not negative reciprocals. Okay? Reciprocals only means flip it. Negative reciprocals means also a different sign. We need to know the difference. I'll have kids who just keep on thinking that would be perpendicular because they're flipped. Okay, next one, number 9. Parallel, perpendicular, neither. This line has a slope of 1. This one has a slope of -1. Are they reciprocals? Yeah, you flip over a 1, you still get a 1. Are they opposite signs? Yes, so these would be perpendicular lines. Another reason, 1 times -1 is -1. You can always test that way. You can multiply the slopes and see if you get -1. Okay, number 10. We can tell the slope of the first line. But we got to get the other one into y equals form to tell the slope of the second line. So we got to subtract 2x. We get -3 times y equals -2/3 x plus 8. We divide by -3. Okay, so we get +2/3 x. I really don't care about this number because it's not part of y, but plus -8/3 or -8/3 would be the equation. The slope is 2/3, so these lines would be parallel. Okay, 11. Slope of this line is 4. Slope of the second line. Subtract. We get 4y equals -x plus 12. I divide by 4. That gives me y equals negative 1/4 x plus 3. This one has a slope of negative 1/4, therefore they are perpendicular. Okay, and my last, I believe, is that my last example? No. Last example, subtract 3x. Divide everything by 5. I get y equals negative 3/5 x plus 2. Slope of this one's negative 3/5. This one, subtract 5x. Negative 3y equals negative 5x minus 6. My last one, guys. Divide by negative 3. Now I'm going to get y equals positive 5/3 times x plus 2. So this has a slope of 5/3. These are perpendicular. Thank you for hanging in there. Enjoy your evening.